So welcome students. In this video we are going to talk about asymptotic behavior of solutions of the linear system. Okay, and this is the second part, linear system. So in the first part we have started out with the constant coefficient system, and we looked at a part of system. When can we say that there exists a solution which is all the solutions are bounded and or they tend to zero? Those are the conditions which you have seen. In this video what we are going to see is basically we are looking at a inhomogeneous problem. So consider this problem. Consider x prime equals to 80 times x plus b of, sorry, not 80 times x, ax plus b, ax plus b of t, right, where a is a n cross n constant matrix, clear? Constant matrix. See, this you have to understand, this system and the earlier system was different. The earlier system which we studied was this, the perturbation of the original system. See, the original system is this, constant coefficient, homogeneous. Now the perturbed system is this, x prime equals to, what are you perturbing? You are perturbing the initial matrix, right? So a is perturbed with a little bit, and the perturbation is a function of t. Yeah, that was the perturbed system, but this is a inhomogeneous system, different, right? So it is x prime plus ax, and then we are doing it, taking a small perturbation which is like given by b of t. Is this okay? And here we'll assume b, okay, is a n cross 1 matrix, of course, n cross 1 matrix with continuous coefficients, with continuous entries, basically, sorry, continuous entries. So this is assumed, clear? Now the thing is, for this assumption, if x at the point 0, let's say, is x naught, then we know from Duhamel, I hope you remember Duhamel, right? Duhamel's principle, or the this thing, prediction of parameter, right? What we know is any solution x of t, okay, the unique solution which passes through this point x of t, that will look like this. It is the fundamental matrix times c. In this case, the fundamental matrix is e to the power a t times x naught, right? Plus this is the solution of the homogeneous equation. So the solution of the homogeneous equation, and then the particular solution of the inhomogeneous equation, which is given by e to the power a t integral 0 to t e to the power minus as b of s ds. That's the you Duhamel principle. I wrote it in terms of fundamental matrix, but in this case the fundamental matrix is e to the power a t. So basically it's just that. Okay, right. Now this, if you want, you can write it like this, e to the power a t times x naught plus integral 0 to t e to the power a t minus s b of s ds, right? Now let's look at something, what happens if we take the norm on both sides. Okay, if we take the norm on both sides, what you can say is that will be dominated by the norm of e to the power a t times x naught, yes, plus it will be again plus 0 to t e to the power a t minus s b of s ds. We can write it like this, right? Why we can write it? This is basically triangle inequality, using triangle inequality. Okay. Now see this term again. You remember in the first lecture when we talked about it, norm of e to the power a t, we wrote it as less than equal e to the power eta t, right? You remember, for some eta we can just do that. Okay, so what I am going to do is I am going to use that fact here. Okay, so using this, maybe I can write it here, otherwise you will make it confused, huh? So using the fact that there exists a eta positive such that it doesn't have to be positive, it can be negative also, but anyway, so it's okay, positive such that, or maybe eta, there exists eta such that norm of e to the power a t is dominated by e to the power eta t. Is this okay? This holds for all t, right? This holds for all t greater than equal 0. Let's just put it this way. Then we can use that inequality here, and therefore norm of xt can be less than equal. See, it is, if you remember, e to the power at times x naught can be written as norm of e to the power at times norm of x naught. Okay, this norm is a matrix norm, this is Rn norm. Is this okay? So this is dominated by e to the power at is dominated by e to the power eta t, right? So e to the power eta t, and this is, let's say, norm of x naught is c, so c naught times e to the power eta t. Okay, and let's say that norm of x naught is given by some c naught, clear, which is of course greater than equal 0. Yes, that is given. So this is there, plus we can say that c times, okay, norm of, I will write what c is here, 0 to t e to the power eta, clear, that eta, this eta, yes, eta, and what do I have here, t minus s, yes, t minus s b of s ds, right, norm of b of s ds. This is okay. I'm just taking norm on both sides and I'm just writing it. And what is c here? This we need to write, where c naught, yeah, is nothing but, we will write c naught as c times c and c naught as c times e to the power, norm of x naught. Okay, it doesn't have to, I mean, see, these are basically constant, so you don't have to worry about it. It's just some constant. Let's just put it that way. Okay, so maybe I can put it this way. It's okay, where c naught and c is a constant. Let's just put it this way. It will be better. Okay. Now what do we have? See, this is fine. Let's call this 2. So we are going to deduce a theorem using 2. Yeah, what is that theorem? So basically the theorem says, it says that, let's say that suppose the inhomogeneous part b of t, okay, is such that, okay, so the theorem says that if you have a bound on b, the norm of b, of course, yeah, what does it mean? That if you know that the norm of b grows, okay, no more faster than an exponential, so basically it is bounded by an exponential map, then the solution will also be bounded by an exponential. That's what it is saying essentially. Okay, so if bt is such that norm of bt, is this okay, norm of bt is bounded, let's call that c3 times exponential gamma t, okay, for large t. For large t, if it holds for all t, then no problem, but anyways for large t we are just assuming. Okay, and where c3 and gamma are constants, okay, are constant with c3 greater than equal 0. When is c3 0? c3, if it is 0, then norm of bt is dominated by 0, which is again dominates 0. So basically norm of bt has to be 0, so all entries has to be 0. So basically we are in the case of homogeneous equation then. Okay, so c3 is greater than equal 0, this we will assume. Then what we can say is every solution, okay, x of t of 1, okay, satisfies norm of xt is dominated by some constant c4 times exponential xi t. Is this okay? For all t greater than equal, how do I put it? Maybe large enough, that is greater than equal t naught, okay, which is of course greater than 0. Where what is c4 and xi, these are all some constants, are constants with c4 greater than equals 0. Anyways, again C4 if it is greater than equals 0, xt has to be 0, right? Similar thing. See, if C4 equals to 0, let's say, then what happens is norm of xt is dominated by 0, and again this dominates 0 since it is norm. So norm of xt has to be equals to 0. Okay, so if norm of xt is 0, that implies xt has to be 0, right? There is no other way. So 0 is the only solution. So basically we are in a homogeneous system case, just like what we talked about in case of C3. So that is assumed. Okay, right. So how do I show something like this? See, proof. The proof is actually not very difficult. Yeah, it's some calculation. See, since norm of bt is dominated by C3 times exponential gamma t for large t, that will imply there exists, let's say, t, how do I put it, maybe t1, let's say, greater than equals 0, such that norm of bt is dominated by C3 times e to the power gamma t, okay, for all t greater than equal t1. I hope this is clear. Okay, see, for a large t this is true, that so I will just choose one t and such that for all t greater than that particular threshold bte is dominated by e to the power gamma t. That's one. Now let's say if gamma is not equals to eta. What is eta? Eta, you remember, this is the eta, this is the eta. Okay, so if gamma is not equals to eta, what happens? Then norm of xt, okay, you remember we are starting from here. Yes, I am not doing this again. Norm of xt is dominated by this, right? C naught times e to the power gamma t. So basically if I am taking e to the power gamma t common, because e to the power gamma t is here also, okay, so let's take it common. This is dominated by e to the power gamma t. Is this okay? Then C naught plus C, some constant C, that's C, okay. E to the power gamma t we already took out, so e to the power minus gamma s norm of bs ds, okay. So it is 0 to t e to the power minus gamma s norm of bs ds. This is what we are left out with, okay. Now see, this is again dominated by e to the power eta t, okay, C naught plus C 0 to C. For t greater than equal t1, I have a bound on b, so I have to use it. Okay, so I will divide this part into 0 to t1 and t1 to t, right? It is minus e to the power minus bs, minus eta bs b of s ds plus c times t1 to t e to the power minus eta s. Okay, norm of bs is nothing but c3 times e to the power gamma s bs, right? I'm just replacing it. Yes, so if that is true, now you see, then we can write it like this: eta t c naught plus, okay, this will just leave it as it is. Okay, so 0 to t1 e to the power minus gamma s norm of bs ds, okay, plus you see c3, this is t1 to t. Now this is nothing but e to the power gamma minus eta times s ds, right? That's what we are going to get. Now so we can write it like this. See, we can write it like dominated by e to the power gamma t c naught. This integral we can do that, so we'll just break it up, plus 0 to t1 e to the power minus eta s norm of bs ds, plus this integral we just break it up, so c3 by, and I will use the modulus here, so it's not a problem, I can use the modulus e to the power gamma minus eta, okay, t1 minus e to the power gamma minus eta, sorry, t and t1, t and then t1 clear? This is what I am going to get. Okay, now this can again be dominated by e to the power gamma t c naught plus 0 to t e to the power minus eta s norm of bs ds, right? plus, see here what I am going to do is I am going to write it like this: cc3 by gamma minus eta e to the power gamma minus eta times t1. Okay, this term I am writing like this. Why I can change it to plus? See, this is a positive term. So basically this x of t is dominated by this particular term minus a positive term. So this will be dominated by this term plus that term also. Okay, so I can just change the sign, it's not a problem. Yeah, since this is positive, the exponential gamma minus eta times t1 is positive, right? Exponential map is positive, so we are using that fact. Clear? So that part plus you have cc3 by gamma mod gamma minus eta e to the power gamma t. I hope this is clear. Okay. Sorry, I should write it like this. Bracket, I have to change the bracket here. Yeah, bracket I should write it here. You see, e to the power gamma t and this e to the power gamma, sorry, e to the power gamma t, this gets, cancel out, right? So e to the power, sorry, e to the power eta t and e to the power minus eta t gets cancelled out. So e to the power gamma t is here, right? That's what I wrote. Okay, fine. So now you see this, we are more or less done actually. Yes. So you see, if you take maximum of eta and gamma, okay. So let xi is maximum of eta and gamma, and we define C4, okay, to be this particular term, the whole term. This is C4, the term in the bracket. I am not writing it anymore. So what happens is, if we do that, then one can see that we have, therefore we have norm of xt is dominated by C4 times e power xi t, right? This holds for all t greater than equal 0, right? And hence it is proved. Okay, so we learnt a beautiful theorem here that if the if the inhomogeneous, the source term has at most exponential growth, then the solution will also have an at most exponential growth. It cannot grow more than that. Yes, I hope this is clear. So with this I am going to end this video.